Guys, I hope you have fun today. We had already few talks, and today I would like to talk about monitoring. I would like to talk about Prometheus, and I would like just to goal of this talk is the following. I would like to convince you that monitoring is important, and I would like to show you Prometheus stack. And additionally to this talk, you will find also a running demo that you can also run on your laptops if you decide that is a good idea to dig deeper into monitoring with Prometheus and with cloud native stack. So my name is Wojciech Barczyński. I'm a lead software developer for SMAC. We are fintech AI. Of course, everybody are doing AI. We also. And that's also my background because now and before, I was working in the startups. So my point of view is startups, fast-moving teams, a lot of technical debt we need to manage, and also like the simple solution that let me just to drop it in, make it working, maybe not perfectly, but then I can learn. And it's especially important for fast-moving environments, and when deadlines are important, and startups is always like that. You have 5 people, and you have work for 20. So why it's important? That's the happy times we used to have. Some of people are still having these happy times with monolith. So we had one big DAG, and now we have DAG links. So understanding the whole dynamics, how the system works, is crucial and very important. And especially when we have a lot of these DAG links. And I have seen a picture, you know, how they show a monolith, like a big dragon, you know, with big teeth. And say like, oh my God, monolith's so bad. So you exchange a dragon for piranhas. Yes, that's our piranhas who are eating developers for breakfast. And because we want to have more information, we employed these 3 techniques. First one is monitoring, which I'm going to talk about. Second is logging, and third one is tracing. And if we compare them, they have a different characteristics. If we take a look on the how much it costs to set it up, CapEx, how much it costs to operate it, OpEx, and whether they help us to react faster or whether they help us with investigation. And if we compare them, monitoring is maybe quite complex to set up, but with Prometheus probably it's very simple. It's have very low cost. So for me, working in a startup where I don't have time to facilitate and manage a centralized logging solution. That's awesome. And of course, we know what is happening because it's monitoring. We know in a couple of seconds that our system is down, that our customers are going to call us or investors. But of course, the minus is that when we need to do investigation, we just know the big picture, but we don't know the data. It's a little bit different than with logging. And with tracing, you can take a look on that. So although I don't know whether it's so low to set up the logging solution, but logging solution, which is the first choice for the most software companies, it's pretty expensive to handle. I don't know whether anybody was handling or administrating so-called EFK, so Elasticsearch Fluentd Kibana. Yeah, that sucks, isn't it? That really sucks. And of course, the third level, but so far I didn't reach this level of maturity with the startups to introduce like end-to-end tracing. And this, for example, I'm working currently. Let's take a look on the monitoring. It's of course it's not a silver bullet, but it's easy to set up and it provides immediate value. So I'm very surprised when I talk with people and they tell me, okay, Wojtek, we have logging, we have Sentry, and we have something else. But when I ask them, okay, do you have any monitoring? You know, you should know at least whether your application is up and down. They're like, not really. Maybe later. So I'm very surprised by that. And centralized logging already beaten this horse, so it's very expensive to handle. And what is monitoring? We are going to talk about numbers, trends, and dependencies, and actions. So we are going to talk about alarm rules based on monitoring. And here's an example of a metric. So on first column, we see a name. So normally, metrics have names. We can describe them as the labels. And of course, we have a value. Not rocket science, isn't it? And what we want to see is to have such a nice looking graph. This is for the demo application, which I was about to show you, but unfortunately, I will see it from screenshots. So for the last 30 minutes, I was running demo and doing screenshots. But you will see it in the moment. Or something more sophisticated. So we know that monitoring is important. Let's take a look how to define the metrics. And there are two approaches. Of course, there are many, many approaches, but there are two that people agree on. So first one is use, and second one is read. Let's take a look on them. First one is use. It's as old as software engineering. It was captured and described by Brandon Breck. If somebody is very known engineer from Sun, he used to work for Sun. Now he works in Netflix, I think. So first, we take a look on utilization, then on saturation, and then errors. Let me to explain you. Utilization. We take a look on it as a percentage. So one disk is running at 90% of utilization. Then we take a look on the saturation. If somebody waits on something, I don't know whether somebody was maybe had opportunity to debug performance issues on the operations level. So you can also see that a lot of diagnostic tools are around these three metrics. And the last one is errors. So when we try to write out rules, for example, we can write a use metric alert rule for RapidMQ. Because RapidMQ has this characteristic that it has some kind of utilization, it has saturation, so the queues are growing, and for example, there are errors. Normally we have also a queue for incorrect messages or error messages to trace how our system works. And for this kind of systems, like queues, use works like a charm. So here's the summary. And when the metric read was defined, people tend to say that use is not very useful for a modern microservice world, but it's still very useful. It's good to know it. It's good to read about it. So let's take a look on the read. It's more for a microservice world, and probably you will not be surprised. It's not very rocket science. So rate how our service is busy, errors, and duration. And this metric is important because it takes a look on the experience that user has. Users are getting mad when we are slow. Users are getting mad when the call is taking too much time. Users get mad when we get errors. So here's also an example. So how many requests per second we are handling, whether we have any errors, and the third one is how long request takes. So it's like no rocket science, isn't it? But it's just a language that, for example, if you read any modern documentation on monitoring, they usually use this term, read. And what is it good for? It's for microservices, especially. So all the REST services, any kind of batch processing as well. And And of course, it's not recommended for anything which has like streaming characteristics. For these ones, we have use. And okay, so we know how to do the metrics, or how to talk about metrics. And let's take a look on Prometheus. This is a stack I'm using in my company, and I would like to just present it to you and show you how to use it. And what Prometheus is, it is a time series aggregator, but it's not event-based. So here what we are going to look at the aggregated data in order to understand how the system works. And we have three elements of the Prometheus stack. First one is Prometheus, second one is Alert Manager, and third one is Grafana. So we are talking about the collection of logs, sending alerts, and the last one is about visualization. Probably Grafana is very known. I mean, everybody uses Grafana. It's a very nice project. And why I like Prometheus, so I'm going to try to convince you, but of course there are a lot of other solutions. It works for me. In startups, it might work for you as well, or might not. Let's see. So what I like about Prometheus is a wide supported technology with with a lot of clients in many languages, from Python, Golang, JavaScript, whatever. There are clients. And second one, I really like about Prometheus, I'm going to show you it, that all the metrics are collected through HTTP, and they're also human readable, which helps to debug any kind of errors regarding monitoring. We have pull model. It depends what is your style, whether you like more pull model, push model. It's, I think there's no perfect one. For me, because I'm on Kubernetes, I'm using a lot of projects from cloud native, so there's integration with them out of the box. And it also provides us very powerful language from QL. So let's take a look on that. So first one, that's how our metrics look like. We use Prometheus client code to implement and provide metrics from your component. And when you open them through HTTP in your browser, you can see them. And it's also a nice format because you can parse it. So sometimes you want to write some ad hoc check that, for example, go through your all your services and collect some data. And it's very easy to parse. And of course, it also have a built-in documentation. So when you take a look on the metrics, then you can understand what the metric says. So this is, again, the same one. This is an example from Golang GC, garbage collection. Similar metrics, you can get it from Python. I forgot to replace it. And second thing, because of the wide support, we have exporters. Exporter is a component that use a native, for example, MongoDB protocol to collect diagnostic data and expose it as a Prometheus. So this is, again, what I really like. I really like solutions where I can drop something and it works out of the box. And most of these exporters just works. You can just put them next to your PostgreSQL or your Memcache or any other database, and then you can collect the data, and then you can really understand how these small ducklings are working with the database. And we also have like some other implementations, so you can really easily to also, for example, in our case, what we did, we had a new stack, which was providing Prometheus metrics. We had a legacy in a startup. And what we did, we deployed a lot of these exporters around our legacy to be able to understand how the legacy behaves and how the new system behaves. So you can then handle both systems in parallel. Okay, so this was about exporters. This is about a cloud native project integration. So if you take any cloud native projects, it will provide you Prometheus metrics. In this case, it's a traffic, which is an ingress controller. You have exporters for Kubernetes and for Istio, you name it, it already provides the support. So next thing which I really like is this very powerful language to define the rules and analyze it. So you have also built-in functions for making samplings, checking the rates, and you can also have more complex operations, like, for example, you can take a look how the data change using more complex algorithms. So this is an example how to use PromQL in your alert rules. So this is the same language. It's here. You can put your query. So you can really define, for example, if your database slows down and your application slows down and something, please wake up Wojciech at 4 o'clock in the morning. But if it does not happen, please don't do it. So it's really powerful because you can really put everything here. And we have 4 metrics supported by Prometheus. First one is counter. So we are just going up and down. We have Gauk, which is, we can change the value. And we have histogram and summary. The histogram is the most useful because it lets us to capture this kind of red characteristic. So rates and in this kind of histogram manner. So here's the example of histogram. Here we have a buckets. So for example, so many calls finish before 0.1 seconds. 107 calls were much slower, and so on. And we can see that 2 calls were longer than 5 seconds. And this is the histogram. This is histogram that let us understand how our service behave and whether we have problem, whether these calls are moving down. And of course, these buckets we can, of course, define. The second one, which is more complex, is this one. This one say, okay, there were half of our calls were shorter than 4 seconds. 90% of our calls were shorter than 5 seconds. Sorry, longer than 5 seconds. No, shorter than 5 seconds. And this also gives us this information, the same like histogram, but different point of view. Okay, and of course we use histogram for latency, and we can also capture the request sites and everything what we can measure in this way. Okay, so I was talking about this one, and this is just side note, the best practice for naming, and also I like it in Prometheus, is that there's a naming conventions for the metrics, and usually they always have a prefix, which is a service name, and the postfix, which is the basic unit. And this is really nice for readability, that you have very explicitly everything stated from the service name and the basic unit that we are going to work with. So that was the introduction to Prometheus. That was introduction to the to how the Prometheus works, and also how to define metrics. And now I would like to connect it with Python. So what I prepare for you, of course, there's support Python client library, but of course it's not the news. Everybody knows that. What I prepare for you, and this is included to the presentation, I using Docker and Python and so on, I prepare you such a use case. So we have an order application, audit service, and the database. So with Docker run, you can set it up on your computer. And when it's running, you have everything. Python, you have Prometheus, which is collecting data from your application. You have Grafana that is visualizing it. It's already connected, it's already integrated, and you will also find examples for Grafana dashboards. And the last one is Alert Manager. So if you want to start with Prometheus and would you like to evaluate it, you can just use Docker run and you have everything set up in 5 seconds. So here's the demo I wanted to show you. So this is the first screenshot. I would run the Docker, then I would show you that it's running. And I also included the traffic generator. It injects the errors. When you will have time and take a look in the code, you will recognize that I'm just calling the service and saying database should fall, service should fall, and so on. So you can really see some interesting data. So we are running this one. We can see the metrics getting gathered. You can go to Grafana, see how it develops. You can also take a look on Prometheus. This is a screenshot from Prometheus. You can play around with PromQL here, and you can also play around with the metrics, which are delivered by this living application in the background. You can also see how the alerts can be defined. This is the most useful one. If your service is down, please wake up somebody. And when you kill the service, you can also see how it works. So then you will see that Prometheus is going to detect it after 2 seconds. Then it will inform you about alert. And then you can also see how the alert manager works. So you can take a look how it looks in the alert manager, how it's going to be. You could, for example, send yourself an email or use Opsgenie to send yourself, I don't know, maybe, get a call, yes? So you could even play around how to integrate your monitoring solution with Opsgenie or PagerDuty. So it's very simple. So you can play around with it and see how it works. And of course, Grafana, so you can see how sexy your graphs could look like. And this is Grafana again. And you can find everything on the GitHub. It's probably 5 seconds. You have everything running, everything integrated. Already you can find out, for example, how the Prometheus configuration files look like, how the Grafana configuration look like, because it's not, for example, very easy to find out how to really define the Grafana dashboards, put it in the file, and then pick it up automatically. Because now there's like few places that it has to be placed, some configuration files. And you also have a load generator, which is created with Werk, WRK, that is going to generate the traffic, so you can really play around with it. For example, one thing that I cannot figure out currently is how to write alert rules. But not me, but to make it more accessible. Because writing good alert rules is very difficult, and there is no, for example, some kind of editor would say me, okay, Wojtek, if you are going to put this as PromQL alert rule, then something will happen. There's no tool like that. So this one I try to use in this way. So I play around and see, okay, is it exactly what I want to have? But of course, with a real application. And when you will take a look in the main PY, you will see a very simple Python application. I try to make it super explicit. And I also provide the support for multi-processing, because without multi-processing, the application would not work easily, because you need to have multi-process to handle Prometheus calls. I think that's all here. Yeah, it's like basic Python stuff. Okay, so you can play around with metric definitions, with metric collection. You can play around with the example of calls. You can play around with the PromQL to really understand how it works. And to sum up, what are the best practices? First one, you need to have multiprocessor, otherwise Prometheus is going to stack your application. I would advise you to start simple. Up-down metric is very powerful, or some kind of load metric is very easy to write, very easy to understand, and then it will not wake you up in the night when there's no problem, yes? And also just remember about, there are some problems with summaries, so better to use histograms. Yeah, so to sum up, monitoring will save your time, I believe, and I believe also that when you start new project, you should start with a very basic monitoring, then focus on testing, and then maybe later focus on centralized logging, because it takes a lot of time and it's very expensive. And for me, checking logs just to find out what is the issue with the application, high level, is like testing versus debugging. Because going and digging into logs with some very complex, long, regular expression sucks. I don't know. I don't like it. And I really like about monitoring that its TCO is very low in compared to the centralized logging. And because I work in the startups, we don't have power to do it ourselves, and we don't have enough money to, for example, use Splunk or other this kind of money-sucking machines which takes care of our logs. So that was all from my side. I hope you enjoyed my talk. And if you have any questions, just let me know. I'm happy to help. Thank you, guys. Everybody
Any questions? I have one question. What if you have different characteristic for traffic during normal week, from Monday to Friday, and during weekends? Is it easy to set up alerts with different limits for
Very
weekends?
Easy.
Yeah,
very easy, because
okay.
Prometheus and this PromQL has built-in functions for day of the weeks, months of the weeks, of the months, days, and years. So you can always say a rule is valid only during Monday to Friday.
Yeah, because I try to do it on Grafana level alert, and it's quite difficult. So, so it's nice to know. Thanks.
Yeah. It's good to know that there are brave guys who are trying it. So then I know who to ask.
Next question.
Did you notice any performance cost to using Prometheus?
No. I didn't. I have never seen any performance issue related to Prometheus. There are so many other big problems than, I mean, scraping logs over HTTP is the last one on my list.
Okay, thanks.
You mentioned monitoring garbage collection in Go.
Mm-hmm.
Do you know anything in Python world that does that in any way?
You can expose also all the diagnostic about running Python program.
Yeah, but I'm interested especially in garbage collection.
I don't know. I don't know.
Okay, thanks.
For like last months, I more focused about Golang, and I have never had a case to monitor the Python or GC, because we are monitoring mostly on application level.
Right, thanks.
But if I would have like high performance, probably I would know.
Have you tried setting monitoring over Elasticsearch, for example, to have centralized logging and monitoring in a single solution?
No, because I believe no. I can have more. I can okay, because I believe that getting logs from getting monitoring or the numbers from logging is like you should have good monitoring. You know, if you are scraping monitoring, if you are scraping metrics from logs, it means that something is wrong with your monitoring.
Yeah, but you can put metrics directly into Elasticsearch using clients similar to Prometheus,
Okay.
for example.
To monitor Elasticsearch or to monitor your, because maybe I didn't understand.
Monitor applications.
Okay. Yeah, I'm aware of the solution, but yeah, for me it's important that developer knows how his application behaves, and he should be the one who defines the metrics.
Hi.
Hi.
I have a question. Do you use this system in production?
Yes.
So do you have a dedicated team to operate it, or
No.
is it so it's developer responsibility?
We don't have, no. Yeah. It's because we are a startup. But normally we would
sure.
also not have a team for that.
Wouldn't be it easier to use some commercial tool like Wavefront, Signal FX, or even Datadog?
Mm-hmm.
Have you considered that?
For me, they're a little bit too expensive. And if you need basic monitoring, I think it should be, it's like, you don't expose differently. You do not outsource a key element of your software, which is metrics. So I would prefer that we are doing it in-house.
Yeah, but in the long run, you would need to pay a price to just maintain it. And from my own perspective, I know it's not easier. And sometimes just to let go and be based on the external company to do it, just save you a lot of hassle. So I understand in testing or for evaluating a product, using something like Prometheus or Elk is great, but on the larger scale, you need to evaluate, is it worth it? Because even if you have an operational team to do it, the hassle to take care of the whole infrastructure take a lot of time and money. And you can spend this money or part of it for a commercial license. So,
Okay, I see your point. It's like this decision, software engineering decision, whether you take it or outsource it.
Any other questions? Thank you, Wojtek.
Thank you very much
For the presentation.